All right, we're live again. You need one of these. You should come get it. Perfect. I'm going to mute this before I turn the microphone back on so that we don't get massive feedback. All right. Sorry about yesterday. I had a grade school emergency that came up as class was about to start, so nobody got advance notice. Crisis averted. We had lunch at McDonald's instead. So, all right, quality metrology. This was yesterday's lecture. We're going to do it today. I'm going to talk super fast so I can go through yesterday's lecture and today's lecture all at the same time. Cool. Actually, the lecture that we intended to have today, this is a pretty good video of me doing that in the past term. So we're going to do yesterday's lecture, start on today's lecture, and then you guys can watch the video so that we don't miss any time in the class and that we can still finish on time and we don't have to use up one of those extra time periods later in the term by having an extra class. Okay? Is that agreeable? Sunday quiz. There were a couple of questions that had problems on the Sunday quiz. I believe Xiaolong has awarded points to everybody that were served those questions. So if you think that you deserve points because the question had a problem, I think there was 2 questions that definitely had a problem. Is that true? And there was about 12 people affected. Okay? So if you think you should have gotten points and you didn't get points back, talk to Xiaolong. Don't talk to me. I would say I don't care, but that's not quite true. It's a little bit true. Okay. It's not really true. I expect all of you to get an A, which is why a quarter of a point here, a quarter of a point there probably isn't going to affect your ability to get an A. Right? Right? You're all going to get an A? Yeah. What's it take to get a 70 in this class? What's it take to get a C in this class? Do all the quizzes and utilize all the attempts it takes to get 100% on the quizzes, right? You guys done that math? Have you figured it out? You actually also have to do the CAM assignments. I think if you just do the quizzes, you get somewhere in the 60s. I think there's points that you'll miss if you don't do the CAM assignments. But we really want everybody to succeed. All right, quality metrology. Everybody's got a card? Quickly answer the question. Which car manufacturer offers the highest quality? Mercedes, Kia, or Chevrolet? Quickly answer the question. Write it down on the card. That's what the cards were for. Today's about quality, right? Which car manufacturer offers the highest quality? We got, I don't know, everybody done writing? Go with your gut choice. Don't think about it. Don't overthink it. Go with your gut choice. Everybody done writing? If you said Kia, pass the card that way, all the way to the end. And to the front. If you said Chevrolet, pass the card that way, all the way to the end and to the front. If you said Mercedes, pass the card to the middle. You guys decide if you're the middle and to the front. Okay, I'd like to get 3 piles. We need more people. We need like a runner. Great. You got the, these are the Kias? We got the Kias over here. Any more Kias in the group? Outstanding. All right, we've got some Kias. Any more Kias in the group? We got Chevrolets, right? These are Chevrolets. Chevrolet. Right? Okay. And the Benz come down the middle. All right. If I had a scale, we'd be really scientific about this. And we could see how much one card weighs. And then we could put them all on the scale and see how many we had. Right? What would that be an example of? What would that be an example of? Metrology? Right? Measurement? So we're going to use another example of metrology. But I'm not going to use a scale. Maybe I should we fire this thing up? Document camera. Woo, upside down. We can fix that. Woo, right side up. Okay. All right, I got Kia. Here's my stack that says Kia. Here's my stack that says Chevrolet. Could we decide which one's bigger? All right, so we're going to go Chevrolet has higher quality than Kia. I got my stack that says Mercedes. Or as my Chinese friends say, Benz. Did I get that right? Pretty close? Yeah. So, I did. Oh, that's the empty ones. Benz. Mercedes-Benz has the highest quality. According to this customer poll. Let's look at the statistics. Oh, you guys can't see that yet. PC. PC. So, what do we know now? For those of you watching from home on YouTube Live, it says here that J.D. Power in 2017, so I mean, some of your data might be more fresh than that, right? 2018s are out now. J.D. Power said that based on problems reported by customers per 100 vehicles, Kia had the highest customer satisfaction. Where, oh shit, Mercedes was down here at the bottom somewhere. So what do we know? What do we know based on that information? So who now changes their mind and says Kia has the highest quality? Anybody change their mind? So the people that liked Kia before still like Kia, right? People that liked Mercedes before still like Mercedes. What does it mean? So honestly, this was used to exemplify a point here. So what does it mean to have high quality? Because I think the study's probably biased too. Because the people that bought this $150,000 Mercedes might whine a little bit more when something's wrong with it, right? The sample might be biased, right? And the people that bought, what's a Kia cost these days? That was the Genesis. That's like the high-end Kia, right? Is that a true term? Oh, Genesis is the next one. Kia, Genesis, Porsche. Yeah, I don't know. Hyundai down here. I don't know. I don't work at J.D. Power. So the sample might be biased, right? Because it's possible that people that spent more for their car will complain more frequently and report more complaints. It's possible that people that spent less for their car will complain less frequently. But what does it mean to have a quality product? How do we define quality? Yes, up in the back. More function. He defines quality as more functions. Didn't you vote for Kia? Yeah. I mean, you were like cheering when Kia came up at the top here, so I guessed you voted for Kia. So what does it mean to have, so what's your name? William. William says more functions is quality. What's your name? Liana says consistency means quality. I forget your name. Spencer says the longer it lasts means it has quality. USA, what's your name? Devin, what do you got? What's quality? We all have an opinion, right? Yeah, what's quality? Dependability or durability. Anybody remember what the ASQ says quality means? That's part of their definition. The ISO definition had to do with conformance to the design specifications or the design requirements, right? And anybody look up what ASQ means? Anybody follow the link? Did anybody do the reading? Wait. Did anybody do the reading? Raise your hands if you did the reading. All right, now raise your hands if you knew there was a reading and didn't do it. Don't be shy, because you're on video. I've done this before. I've asked this question. I said, did anybody do the reading? And 3 hands in the class, 70 people, 3 hands go up. I said, who knew there was a reading? All the hands go up. And then I say, who knew the reading was watch 2 stupid YouTube videos? Sometimes my reading assignments are watch a video. Did you notice that? Yeah. Okay. So anybody look up ASQ? I provided a link to it in the reading. No? Oh, you can. Oh, I didn't know you can't click it. I can fix that. I can make it clickable. Did anybody look up ASQ? Did anybody care? These are the people that certify quality engineers in the United States and around the world. If you want to be a certified quality engineer, you get your certificate from ASQ. I think it used to mean the American Society for Quality something, SQ. Yeah, American Society for Quality. All of these American societies now have changed their name to just be the acronym or the initials. So it used to be Society of Manufacturing Engineers, SME. It's no longer the Society of Manufacturing Engineers. Now it's just SME because they want to be an international organization. The American Materials Society, American Society for Materials, ASM, is now just ASM, not Americans. Yeah, all these societies have done that to become international. So what's quality? What's the beginning of the ASQ definition for quality? Because they do quote the ISO definition, but that's not how they start. Anybody remember? The ASQ, the people who certify quality engineers, start their definition for quality by stating that quality has many definitions and it depends on the situation and the observer. The people that certify quality engineers say that, yeah, it depends. But the ISO, International Standards Organization, they define quality as what? You said it earlier. Conformance to the design requirements. So in manufacturing engineering, as we're doing our manufacturing, if we want to create a quality product, we have to give the customer what? What do we have to give the customer if we want to create a quality product? Yes, Gus. We have to give the customer exactly what they asked for, exactly what they wanted, exactly what they need. Yes?
Just after that, on the website, it says quality is business use, the requirements, and
they say that somewhere on their website too? Yeah, in their glossary where they define the word quality, they say something else. And it's quoted in the reading. But what is quality? It's conformance to the thing the customer wants, right? It's making the thing the customer wants. So does that mean that Mercedes can have a high quality product? Does that mean that Kia can have a high quality product? They don't have the same customer, right? So neither one of them can we argue as higher quality unless we can track the customer's desire relative to the thing that the company's producing. All right. So how do we know if we have quality? Yep. So as a customer, you feel that you are receiving quality from somebody that's giving you some parts, right? Who made those headphones? You know? LG. All right. Is that a quality headphone? It provides the needs that you have, right? Yeah. Bose makes pretty good headphones, right? They're a little expensive, like $300 for the earbud ones. I used to have those. They literally broke in half while I was wearing them. That did not meet my customer needs, especially after paying $350 for them. After just over a year, just out of warranty. So I guess they knew their design life. What they didn't anticipate was that I was going to wear them about 20 hours a day and always be using them because I work in a machine shop. And it's noisy in the machine shop. And so I would have them in my ears just to block out the extra noise so that I don't damage my hearing. Right? They didn't anticipate me as their customer. These made by Safe Sound. No, Safe Sound is the trademark. ISO something or other are designed for such use, so they say. I've only had them for a couple months. We'll see how long they last. So we know as customers that we have quality because we feel it. We believe it, right? As the manufacturer, yes? All right, as somebody that sells something, if our customers keep coming back, then we can infer from that information that our stuff doesn't suck too bad, right? So we can infer from that we might be producing some quality because the customers keep coming back and keep buying from us, right? What if we want to know sooner that we have quality? And as the manufacturer, so as the person that's just about to ship the parts to the customer, what if I want to know if I have a quality part? What do I do? So somebody said inspection, right? So what does it mean when we say inspection? What do I mean? So inspection is a step. Is a step in the manufacturing process, right? So how do I inspect? Yeah, Gus. So we have specifications. Is there a trash can over there somewhere? All right. I have been teaching in this room for about 12 and a half years. That is the first time I've ever hit the trash can. But I have thrown shit at the trash can many times because there's nothing worse than a whiteboard marker that the students can't see what you wrote on the whiteboard in the front of a classroom. Okay. But it was Gus, right, that said we have a list of stuff. We'll call that list our specifications. All right, so inspection involves specifications. But what is inspection? So he said measurement. So in order to do inspection, it involves measurement. Yes. Measurement, I'm going to say testing. You said stress. In a week or so, we're going to actually define engineering stress. But what did you mean when you said stress? Okay. Any rock climbers in the group? Yeah. Would you rather buy carabiners that have been tested or just carabiners that have not been tested? Right. So there's some products that we want to do a test on each part before we ship it out too, right? So a stress test though sort of implies to me that it's a destructive test, right? You're gonna work this until you wear it out. I did some work for Goodyear, the people that make tires, and I was on one of their test tracks. Actually, I've been to 2 of their test tracks. But so say Chevrolet wants to have a quality product, and they're gonna ship their new Chevrolet with Goodyear tires, right? Because people believe Goodyear makes quality product, right? Oh, what did our little poll tell us, by the way? Mercedes has good marketing people, right? Yeah, that's what our little poll told us. So GM will give Goodyear the car that they want to put the tires on. Goodyear will formulate some tires and some compound for the rubber, some design for the treads. They'll make those tires in a short production run. They'll put them on that car, and then they will proceed to drive the rubber off of those tires so they can understand, one, they put all kinds of sensors in the cars and stuff like this, like what's the road noise, what's the vibration level, how long do they last in these conditions. They put them on a skid track. They had this giant, like, I don't know, 2-3 football fields, like stacked next to each other. Asphalt, flat, that they could cover with water. They could literally put like an inch of water on this whole thing. They could drive in the wet. I think you could tow a water skier with the car on this thing. I never observed that happening, but I believe that it was enough water to float a water ski. So that's the kind of stress testing you were talking about, right? That's kind of destructive testing. And you do that to establish a new product. And you have to do that with some kind of products. What else? What else is inspection? Yes, sorry. Comparison. How many R's in comparison? Years ago, I didn't ask questions like how many R's in comparison, and I would just go for it. And when I would spell it wrong, invariably, there would be somebody in the class, well, I think there's probably a lot of people in the class that would notice. Invariably, somebody would say, you spelled comparison wrong. And I would throw them the red marker and say, you're in charge of the red squigglies from now on. And people would think that was funny the time I did it. One term, a student actually kept the red marker the whole term, and he would get up and do red squigglies every time I spelled something wrong. It was kind of cool. All right, comparison. There's actually a metrology device called an optical comparator, where you can actually, you look at the shadows on these things, but they have digital comparators too. So yeah, comparison. You have a gold standard, and you compare it to the thing that you've made. So comparison is a metrology or a measurement tool. What about, that's pretty good. Is that inspection? We can do a visual. All right, so how do we know if we have quality? We do some sort of measurement, right? So you guys can't see the thing, huh? If I clearly look like I'm talking to the computer and talking about the thing that's on the computer screen, and you're looking at the whiteboard on the thing here, please tell me. Because I'm not looking that direction. I don't remember which one I'm showing. Anybody know who said this? Famous quote. He said some other stuff. To measure is to know. If you cannot measure it, you cannot improve it. Any guesses who said it yet? He's famous. When you can measure what you're speaking about, and you can express it in numbers, you know something about it. When you cannot express it in numbers, your knowledge is meager and unsatisfactory. Anybody? Any guesses? They were alive at, you know, what, I don't know, when was Tesla alive? Anybody know? Anyway, another one of those old guys. It was not Tesla. It was Lord Kelvin. So yeah, Tesla, he overlapped with Tesla in time. He also said that X-rays will prove to be a hoax. So not everything he said was necessarily, well, actually, I don't know. What do we really know about X-rays? Us sitting in this room. I think I know something about them because I studied nuclear engineering as an undergrad. But I don't know. What should we measure? We're going to measure stuff. What should we measure?
Things we want to have quality.
So we could measure stuff if we want to provide quality. All right, so let's think now more in terms of physical terms. What can we measure? We can measure size. We measure size. And what's size really? It's length. Right? So if we're measuring the size of something, we're measuring some combination of lengths about that thing. So we can measure length. What else can we measure? I wonder if it works if I shoot it at that one. Autofocus. Where's autofocus? I think that works. What else can I measure? Yeah. Size. I can measure size and weight. What else can I measure? Volume. Yeah. I'm not going to write down volume because volume is just like size, isn't it? Is volume different from size? What are the units for volume? Length cubed, right? And size is just a bunch of lengths. Yes? How about we call that time? Yes? Location. Why did I write this down when I didn't write down volume? Right, because it's also got units of length. Right, or we could express it in units of length. Right, because it's really different from size. That's why, because I chose to. I'm the guy with the whiteboard marker. What else can I measure? Yes? Surface texture. How do we measure surface texture? We could use a profilometer. It's not the only way. We could visually inspect for surface texture. What else could we do? We could use a comparator. Your thumbnail makes a really good comparator for surface texture. Pick two surfaces right now. Run your thumbnail across one surface and then another surface. Can you immediately know which one's rougher? Which one has... Now, I said rougher and people said yes, right? What does it mean to be rougher? Yeah? A more inconsistent outer diameter. So a more rough surface, if you were to follow the surface perfectly with your thumbnail, would be longer if you stretched it out. Anybody from Vermont? Anybody in the classroom from Vermont? Really? There's usually somebody in the classroom from Vermont. Anybody ever been to Vermont? Okay, good. Anybody from Texas? You got one Texan. Anybody else? Anybody ever been to Texas? Fewer than have been to Vermont, but we're closer to Vermont than we are Texas. Did you know that in Vermont, Vermonters truly believe this, that Vermont would be bigger than Texas if you could flatten it out? And I have been involved with a group that was able to mathematically prove that that was true, with a few caveats. You had to assume that the subatomic particles in Vermont were rougher than the subatomic particles in Texas. And in fact, it helped if you didn't flatten out Texas at all. Because you really had to get the subatomic scales with the flattening of Vermont before Vermont could get bigger than Texas. So rest assured, who's the Texan? What's your name again? Jenna. Rest assured, Jenna, Texas, bigger than Vermont. Doesn't matter how much you flatten out Vermont. Right? But that's what you're talking about, right? If we could flatten it out, it would be longer. Sure. There's a parameter which we do that. If you're looking at a profile of a surface, we'll call that length scale area or length scale fractal analysis where we do that. Yes?
Well, that kind of gets into the coastline problem. Like,
It's exactly the same as the coastline problem.
You can argue that the coastline of Britain is infinite because it just depends on what size of the small unit.
Yeah, so exactly, which is why we had to flatten Vermont out to those subatomic particles, right? To get Vermont to be bigger than Texas. So yeah, there's actually that whole research area in surface metrology about the coastlines and the profile lengths and the flattening out of areas, that was actually developed here at WPI. On the other side of this wall in the WPI Surface Metrology Laboratory. Yes?
Just a question, so you're saying that roughness is, something is more rough if it is longer, or?
No, I didn't say that. He said that. What's your name? Ian said that. I didn't disagree with him. It has many meanings. What you're feeling when you do this, when you go across that surface, so you're moving, right? So you had to have velocity before you could feel that roughness. Your thumbnail's vibrating as it goes up and down. It's actually just like dragging a record player needle across a record. You guys know what those are? You're just checking. Because you could also do it by having a laser go across that rough surface if you could look at the reflected laser light, right? And so there's different ways to look at that reflected laser light to see how long it took to get back, to see what angle it got diverted to. And so you could actually triangulate the height of that point on the surface to a laser sensor. And then you could drag that across. And if you did it in 2 dimensions, really 1+ dimensions, if we're going to let the physicists believe us. Oh, is there other stuff we can measure quickly before we go on to surface metrology? Because we could talk about surface metrology for a long time. I did my doctoral work in surface metrology. Is there any other things we can measure? Can you pretty much measure anything you put a number next to? Right? Did you know that you can measure color? Yep. I once built a colorometer to measure color. Turns out the name's pretty easy, self-explanatory. Could you measure angles? Anybody know what you use to measure an angle? Yes? You could use a protractor. Yeah. What's that? An angulometer? Yeah. Yeah. So we actually wanted to, you guys know like when you put a drop of water, sometimes it spreads out. Sometimes it stays a drop, right? That phenomenon is called wetting. When you want to measure the angle of the water droplet as it interacts with the surface, use a tool called a goniometer. I don't know, maybe the guy that invented it had been watching The Goonies before he invented it. A goniometer. Use those to measure the angle of the water droplet as it's impinging on the surface to see how wettable the surface is. So we could measure wettability. Soap makes water more wet. Depends on what you put it on, right? It'll just beat up and roll off a lotus leaf. If you put Rain-X on your windshield, you change the surface of that windshield, the water doesn't stay on it. It beads up and rolls off, so that windshield doesn't get wet from the water. I think the water by its nature is wet. But what it goes on, what?
I'm looking at your YouTube live. I'm just saying, this on YouTube now.
I think water really is wet. But it doesn't make everything wet. Is that fair? All right. So let's spend some time talking about surfaces because, well, I care. And there's questions about surfaces on your quiz. So as we take our record player needle and drag it across that surface, you're the one, it's Liana brought up this, I think you said the word profilometer. So that's actually a brand name. It's like Kleenex.
Okay.
But a profilometer, and because people use it just like Kleenex, like give me a Kleenex, give me a profilometer. You might get a profilometer that's not made by Mar Federal, and it's Mar Federal that makes the profilometer. A profiler. Those are the guys that work at the FBI too, right? Yeah. All right, so, but it's got a little diamond stylus, typically a diamond tip. The whole stylus is not a diamond. They get like I think the one we have downstairs has got a little aluminum shaft with a piece of diamond on the end of it. And as it interacts with the surface, it goes up and down. Does that make sense? You drag that, when you do it with your thumbnail here. By the way, they make comparative samples for the thumbnail thing. So you can have a little comparator in your pocket. You walk over to the part. Yep, that's a good part. You guys don't believe me. You're laughing. Do you know that that's the metrology test that the Navy uses when they're buying nuclear submarine components? That's how they test the roughness on the welds. So nothing much, just the thing that keeps the pressure vessel together. Right? That's a valid test. And you get really good at this. You can actually feel about a 10,000th of an inch by moving your thumb, without the thumbnail, just the skin of your thumb, moving that across. If there's a height change of about a 10,000th of an inch, you can feel it. All right, so we call this a profile. Of our surface. The profiles are pretty cool, right? I missed some good slides. I know, I'm trying to jump ahead. So that's a profile of the surface. What do we know if we look at that profile? It's not smooth. What if we compared it with this profile? What do we know? They don't have the same mean value, right? Well, actually, those two might have the same mean value, but they don't have the same best fit line, right? The slope of the best fit line is not the same, right? They might have the same mean value. I don't know. So what do we know when we have a profile? What if I have that profile? In that profile. Yes. You would call the top one rougher, right? Anybody disagree with that? It's Ian, right? By Ian's measure, the top one's rougher, right? It's longer. If you flattened it out, it would be longer. Is it rougher? So how do we carry? So what we know right now is we have a picture, right? Picture's worth 1,000 words. You guys have heard that? I'm an engineer. I really want a number, not 1,000 words. So how could I turn that picture into a number? Yes, Ian. So we could integrate the arc length, and we could find a length. It's actually, when we do this in practice, what we like to do is we like to get a relative length. So what we like to do is we like to see what's the length compared to the projection. So that way, if we had two profiles of different actual total length, we could compare them both to their projected length. So we can look at a relative length, right, of this. So we could do that. That's one way to differ, and this one would have a higher value than this one, right? Intuitively, we just know that. What else could I do? Now remember, even when we did our record player needle to drag it across here, or we used our laser to drag it across, or we used some sort of 3D imaging system, and then we extracted one of the profiles out of it just to examine one profile. When we did this, even with that record player needle, it's an analog process of dragging that record player needle across, right? But we're going to use a computer to do our math. You believe me? Yeah, we're going to use a computer to do our math. So we digitized this signal. So what we actually know is a bunch of little points along this. Right? So we've digitized this. We've got a bunch of heights. And it's, so this is height H. It's also Z, depending on what you're looking at. And this is X, if we pull the profiles out in the X direction, if we had a 3D surface. So that's X, that's Z. We've got a bunch of heights. So what can we do if we've got a bunch of heights on an axis? Yes? We could count the number of peaks. That's a peak, that's a peak, that's a peak, that's a peak, that's a peak. We could do that. What about this one? Is that a peak? Is it a peak? Is it not a peak? As soon as we start doing things like counting the number of peaks, which we can totally do, we have to specify some sort of a scale. So the highest point within some dimension to call it a peak. All right, what's the highest point in New England? Top of Mount Washington. What's the second highest point in New England? Monadnock? Lafayette? Anyone else? It is right next to the highest point. Second highest point in New England, right next to the highest point. But when I asked the question, you inferred some scale, right? It gets back to the peak counting thing. So yes, we can absolutely count peaks, but we have to define what it means to be a peak. How far away from the most adjacent peak does it have to be before we call it a peak? Same thing. You did your relative length here. You did your relative length at the finest scale of measurement, right? You measured from this point to 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 this point. Divide by the. What if we took our dividers, went back to our coastline of Britain argument, and what do we said? Well, what's this one to this one to this one? And we added the lengths of all these together. We had a longer ruler, and then we divided by the relative length. Would it be bigger or smaller than your number? Right. So it turns out that if we measure, and when we do it in a computer, it's really easy, right? Because we just let the computer do all the math. So we do this relative length where we take these calipers and go along our surface and find out how long the surface is, divide by the projected area. Then we do it with slightly shorter calipers and do it again. If we do that and we plot it where scale is here, and that's the length of the individual calipers, and relative length is here. So that's the total of all the calipers added together that we got across there, divided by the projected length down onto our axis. And this is log, and this is log every time. For every surface that we can investigate, we had a graph that looks something like this. That's cool math. When you can apply it to any surface and you can get a graph that looks like. Now, some of them might look like this, but they all exhibit this sort of dinosaur head shape at some point along their graph. What it tells us there so there's almost always, and this is usually like 2 or 3 decades on the log scale. This straight line area here. Over this range of scales, that surface exhibits complexity. That surface is rough over those range of scales. Anything that interacts with the surface that's bigger than this scale sees the surface as being smooth. Doesn't notice the roughness. And when we get up to these scales, it could be that the complexity is changing. And it could be that our measurement tool has run out of resolution. We may have a finer sampling interval than our ability to resolve things with our measurement tool when we get down to this scale here. So in this range of scales, and it works for an aerial measurement of a surface as well as for a profile that's extracted from one of these aerial measurements of a surface. But in this case, instead of putting lines on the surface, we put little triangles on the surface. And we look at the area, and the total area of those little triangles, and the total area of the projection of that surface down onto a flat plane. And so what we have here is called the fractal complexity. And the slope of this line is related to the fractal dimension of that surface. Anybody know what a fractal is? Anybody heard the term fractal before? A few of you have heard the term fractal before. So a fractal is, you know how some geometries you can define them with a formula? Right, like a circle, what's the formula for a circle? X squared plus y squared. Formula for a straight line? Y equals mx plus b, right? Right? Some geometries we can define with a formula. Fractal geometries we define with a pattern. And so, you ever looked at a tree and you see the leaves branching, like the branches of a tree? And then you zoom in on one of the branches, and doesn't one of the branches of a tree look sort of like a tree all by itself if you zoom in and all you can see was the branch? And then you zoom in on that branch and you look at the twigs coming off, and it still looks sort of like a tree as long as you don't have the idea of what the scale is. You zoom in on a leaf, and inside the leaf you've got the structure that still looks like a tree, right? So that's a fractal pattern. So that tree is made up of this pattern regenerating over time. There's mathematical patterns that you can do. And so surfaces that obey this are called self-affined fractal surfaces because at some sufficiently fine scale, they stop following that pattern. All right, so this is cool because when we do our thumb up and down, we're noting that up and downness, right? What we really notice there, well, we notice the frequency and the amplitude, right, of our thumb going up and down. So this complexity thing here, that includes frequency and amplitude in one measure. What else could we do if we had a profile going across? Right? We could measure things like the height from here to here. Right? That would be like a peak height. When we're doing all these profile analysis or an aerial analysis, whatever it is, the first thing we do, because we'd like the math to be easy, right? Someday ask me the story about the time the department head waved a printed copy of an email in front of my face, quoting a student who was complaining that the course wasn't difficult enough. I guess I'll just tell the story now. We'll get more on this in the video. He said, the department head was mad at me because in class I used to say, I'm lazy, so let's find an easier way to do this. Right? Trying to implore you to find an easier way to do this. By the way, I believe, and I have not tested this, there are 0 quiz questions that I will ever ask or could possibly ask that if you highlighted the question and right-clicked and said, search Google, you might not find the exact answer, but you will find the method to solve the problem. So please, if you can't figure out how to answer one of the quiz questions, do that. Except when Jiaolong puts the wrong answers in. When that happens, it's possible that you can't find the right answer. But yeah, and if you do think that there's a mistake like that, please point it out to us on the discussion forum. There was, on one of the problems that had a mistake, there was a lot of discussion. Thank you guys for trying to work that out and figure it out. Yeah, I didn't cover enough surface metrology stuff yet. And I missed my favorite slide in this presentation, so I'm going to go back to it just to end on that. You guys have all seen one of these, right? In God we trust. Did you know if you zoom in, it says everyone else bring data? It's my favorite slide in the whole presentation. I had to use it. But I will post links to some other videos of me talking about this stuff. And we're going to go with the quiz on Friday and the quiz on Sunday as planned, but I may scale back the questions since we didn't necessarily cover everything. But I don't really want to get behind in the schedule because next week is a busy week for us. If you're gonna skip class in this class, please do not skip next week. Next week we have 3 classes, and we're going to talk about stuff. Some people say it's the hardest part of the class. It's a good week not to skip class next week. I don't think it's the hardest part of the class, but then I had been teaching that material for about 6 years before I thought I understood it. So it might be the hardest part of the class. All right, so next week, come to class. If you can't come to class, watch the video. Let me turn this off, unless you want to be on camera when you talk.